Hello, in this video I want to describe the crimping that I've done, wire crimping, on my Helicycle N750 Golf. Some of the industry standards and practices that I think you should be familiar with before you get started. Here are three terminals that at first glance appear to be the same, but they're definitely not. And I'm going to get into this in great detail as we go. This first one over here is the worst. This is garbage. This is junk. This is a good terminal. What's the difference? There are two halves to these crimp terminals. The first part is the portion where the wire actually gets crimped down in here. Second portion, which is equally important, is the part that acts as a strain relief. So there's got to be a metal section back here that gets crimped. And you can see a little clear on this one that it has that section. This thing doesn't. Now the problem is that as this wire flexes over the years, it's all going to take place in this terminal right back here where the wire exits the crimp area. And in the same way that if you continually bend a paper clip back and forth, eventually it's going to break. That's what's going to happen, or what could happen, on the terminal on the left. That's the sort of terminal that you'll typically find at a hardware store or an automotive parts store. Now these next two you might find at an electronic supply. One of them, the one on the right, is an amp PIDG terminal, and those are the ones that I strongly urge you to use. The difference is that this has a funnel. You see how smooth that is? So as you feed the wire in, it's going to direct all the strands down into the barrel area where they get crimped. With this middle one, what often happens is you don't come straight in through the middle. You can't see in there that well. You're just doing this by feel. And a couple of the strands could get bumped up against the side here, this sharp edge, and they'll just get pushed back and wrapped up in this area where they're not even getting crimped. And that's going to produce a bad crimp, and something that's very difficult to see when you inspect your crimp, because this will be squashed down over the braid, so you won't even know that all of the strands didn't even make it in there. So this is the one you want. Here's a picture of those same three terminals. You can see fairly quickly the one on the left has just a cheap piece of PVC tubing over the back, and again you could look inside and see there's no metal in there. There's no strain relief whatsoever. So that thing is clearly a piece of trash. The next two, however, they look pretty much the same. So the only indication you have that you've got the kind that has the funnel in it, the best kind of all, is to simply buy amp PIDG terminals, and you can get those at the same four electronic supply places online that I've mentioned over and over. That would be DigiKey, Mauser, Allied, or Newark. They're all online. The other giveaway that things aren't quite right with that center one is there's some labeling that was stamped onto the terminal, and it's sort of missed. You can't read it because they did a sloppy job. So stay away from the cheap terminals. Don't go to the hardware store, or don't go to the auto parts. Go to one of those four suppliers and look for amp PIDG. Now, the reason you want to do that is there's a mill standard called mill T7928, and only terminals that pass that, all these stringent tests that are listed down below, get sold as having met that standard, and amp PIDG does meet that. So what they do to qualify for this mill T7928 is you pull samples out of every lot and you run them through all these tests. If even one terminal fails, that whole lot gets rejected. So look at some of the things that that the manufacturer is going through to ensure that you get a good quality product. They're going to do 50 current cycles at 20 amps, then they're going to vibrate it for 18 hours in 2 planes with a 16 amp test current, test it again. Then they're going to pull the wire to destruction and check it, and I'm going to do that later to show you how that works. They're going to immerse it in lube oil and hydraulic oil at high temperature for 20 hours, flammability test, salt spray, heat, aging, low temperature tests, axial load tests. They go through all these tests on samples from every lot, and only if they pass all these tests do they get passed on to the distributors for sale. So if you stick with AMP PIDG, you're going to get a really good terminal, and it's going to make a good joint, as you'll see later in this little video. The other reason to stick with those terminals is there's a whole family of tooling that goes along with them, and I'm going to show you 2 crimpers. These are a family of crimper called self-completing Ratchet Crimper, and what that means is that this assembly down here is a ratchet, and what it does is it will not let this tool open up and release the terminal until it's completed the crimp. So once you start, it can only go tighter. It will not loosen until it's all the way done. That's the secret of a good crimp. Now this one I like best. It's an AMP 59250. You can find these online on eBay or maybe Craigslist, something like that. It has 2 sides to it. It's called a T-crimper. It will do smaller terminals over here, which are color-coded red, and larger ones over here, which are color-coded blue. Now the beauty of this tool is if you find one online and it says AMP 59250, this is what you're going to get. The die is part of the tool, so you won't disappoint yourself and find out you got the right body but the wrong die. Now the next one that's very common, it's a very high quality tool, is this Daniels HX4, but that's only the body. That's that gold part that you see there. And again, it's a self-completing ratchet. There's the ratchet part right there. The problem with this one, it's a beautiful tool, but the die up here can be removed. You punch out these pins here and here, and you can put a different die in. So the problem with that is you can get an HX4 crimper and you think it's going to work, and then you find out it's got the wrong dies in it. So it's a little more complicated to find what you want in Daniels because of that. Now the terminals, at least the industry standard and something that AMP conforms to, is this color code. So over on the left you see the colors, yellow, red, blue, and then yellow again. The wire size is all the way from 26 up to number 10. So again, that AMP one did red and blue, so it can cover wire sizes from 22 gauge up to 14 gauge, and that's a pretty good range for the Helicycle. Most of the wiring that you'll do will probably be in that range, the smaller stuff anyway in your instrument panel. Bigger stuff you're going to need a different crimper anyway. So again, I've showed you the AMP 59250, what it will and will not do, and the Daniels. And also the Daniels has a middle part number, M22520/5-01. So you might look for that online as well. And then the Daniels dies on the right that you're looking for. To match up what the AMP tool does, you'd be looking for that Y671 and 672, 2 different dies. And again, that's a slight disadvantage. The AMP will do 2 different sizes. The Daniels won't. You'll need a different die for each size. Now here's the picture of the amp tool. This is a surplus tool that I bought. I think I got it for $5. Probably you're going to end up paying $100 online for a used one. So I lucked out. I got this thing probably 25 years ago. You can see the paint's falling off. It's pretty dented up. But the important part is the sophistication of the die itself. You can see that there are two different portions of the die. The one part crimps the wire, the other makes the strain relief, and you see the geometry is fairly complicated in there. So, when you get a hardware store crimper, take a look at the thing you've got in your toolbox out in the garage and compare it with this picture. It's not even the same ballpark. So you definitely want to use something like this. Now remember, in my solder video I talked about an ANSI standard that applied to soldering. There's actually several. And I also wanted to mention a book that you can get probably at your local FBO. It's called Aircraft Inspection, Repair, and Alterations, AC 43.13-1B. It's about 2 inches thick. It's put out by the FAA. It's got a lot of great stuff in it. You should definitely buy that before you start working on your helicycle. It's got everything you need. It's almost like a textbook for A&P mechanics. And it will cover a lot of the stuff I'm talking about, and it is readily available. Anyway, getting back to acceptance criteria for Class 3, this is what the industry standards for Class 3 are for stripping a wire. And you should stick to these. It's very important. The first thing is the strands are not scraped, nicked, severed, or otherwise damaged. And you can see a picture of a wire I stripped. The problem is if you even nick a couple of these strands, if they flex, eventually they're going to just break off. And now your wire's been weakened and its ability to handle current goes down. That weak point with a lot of current going through it is going to heat up, and it may fail. So that's not good. So you want to make sure you haven't nicked or scraped the strands. Then deformation, you want to make sure the strands are not flattened, untwisted, buckled, kinked, or otherwise deformed. No bird caging. Bird caging is if you pushed on the end of that, the center part will expand out and it'll look like a tiny bird cage. That's a no-no. And then last is the insulation. It shouldn't be pinched, pulled, frayed, discolored, charred, or burnt. So those are pretty obvious. The main thing is don't nick the strands when you're stripping the wire. Now here's a shot of the Daniels crimper getting ready to make a crimp. And you can see there's a number of sections to this crimper. This part over here holds the terminal during the crimp. And they try and make these things as idiot-proof as possible. So as you place the terminal in the die, you just push it all the way up till it bumps into this little block here. See that? So you go all the way up here, and now you're assured that the die is lined up properly. This part is going to do the crimp, and you can see here's the area where the crimp goes right there. See that? This part is going to grab the back here, and it's going to make a strain relief. Now here's what the terminal should look like after it's crimped. No insulation in the conductor crimp area, which would mean you stuck it in there too far. Conductor end visible within the brush inspection window. And what that means is you want to see the strands sticking out here. They have to go all the way through this section. It's critical to get a good crimp. This is the part that gets crimped right here. So it's got to go through this whole section. The only way to know that is if you can see a little bit sticking out. No conductor strands broken, folded back in the crimp area and not captured by the conductor crimp area. That's what would happen with that first terminal on the left that I showed you, or the second one, where they could just bump into the back of that area because there's no funnel. So the amp PIDG terminals all have a funnel, which makes it much more likely that all of those strands are going to get into the right area. The other thing, that fourth bullet, crimp indentation, uniform and meet contact tooling manufacturer requirements, that's something we're not going to really worry about. But you see this little dot here? These industrial crimpers make little marks on the terminal so an inspector can come along and go, okay, you know, for a red one using that die and that crimp tool, it's supposed to make one dot. And if he sees two dots or an X or whatever, he'll know, oh, that guy used the wrong tool. So in our case, we don't have to really deal with that one. The next one was minor deformations of the contact is acceptable if it doesn't alter form, fit, or function. So again, the tool may bend the terminal a little bit during the crimp. That's okay. Now, here's the really important part. And this is where that terminal on the left doesn't even have any metal in the back. This is the strain relief area. You see what a nice, neat job that did? It's just very smoothly got a good grip on the insulation. It hasn't squashed it. It hasn't deformed it. It's just got a good grip on it. And so any flexing that happens is going to happen back where the wire is nice and strong, where the insulation is covering the wire, not right up at the back where the crimp is. So this is going to make a much, much more reliable crimp. This is, again, this is the back end of an amp PIDG terminal, which was crimped with the proper crimp tool. Now here you see me actually making a crimp using my old beat up crimper. This is another one that I didn't show you that does little white terminals. Now again, you can see the wire sticking out through the brush inspection area farther than it really should, but I just slapped this together just to show you how a crimp gets made. You can just barely see, things stopped out of focus a little bit, but this is the area where the wire is crimped. This is the strain relief area here, and again you can see the outline of the strain relief. You see that? That's important. So this whole portion here has got a good grip on this wire, so any flexing or pulling is not going to all happen and get focused right at the back end of the crimp area. So again, you got to use the right tools and the right parts. The next video I'm going to show you, we're going to actually test one of these, this very crimp as a matter of fact, to destruction. So let's see what happens. Alright, let's try this. So I've got my spring scale tied on the end of this wire. The other end I've crimped with a standard amp PIDG white crimp terminal. It's a 22 gauge wire, and I've tied a little string 6 inches away. So let's see if the wire stretches, if it breaks, if the crimp fails, or if the wire stretches and then breaks. Here we go. I'm going to start pulling right now. 10, 15, 20, 25, yeah, 30, 31, 32, 33. Now this time it broke. So let's see what we got. Okay, you can see that the fish scale shows that I got up to 33 pounds before that failed. So now the question is, what failed? What we don't want to see is the wire pulled out of the crimp. It should have broken somewhere. So here's our wire. Remember, from that dot all the way through to the brush inspection area was 6 inches long before we started. Now that wire is stretched to over 7¼ inches. So it's stretched just in that 6-inch length over 1¼ inch. There's a little closer view. So look at that. And it's interesting that the insulation also stretched, but as the wire snapped off, it looks like the insulation bounced back almost to its original 6-inch length. Not quite, but it left all that exposed wire sticking out the end. That wasn't there before the terminal broke. So let's take a look and see how that terminal looks. Well, there you go. See that? The wire broke. There's the crimp. You know, that held. The wire snapped right up here. If you looked in the end of the terminal, you would see that the wire is busted off right in there. I have no way to get a picture in there with the cameras that I have, but trust me, that was a good crimp, and that's what you expect to see, is the wire failed. You can't get any stronger than that. And of course, you always leave the strain relief, so there should never be any tension on anything. There's always got to be room for flex. So there's no reason that there would be any pull on any wire with a terminal in it. And even if there was, you saw, 33 pounds is an awful lot of pull on a little bitty wire like that. So I hope this has been a good quick introduction to crimping and the proper kinds of tools that you should be thinking about using on your Helicycle. And that's the end of that. I hope this was of use, and thanks for watching.